Well, basically at OCR, what I do is I was involved in developing a lot of their computer science specifications, and I write a lot of the exams that students sit. And it is in the context of that that I'll just sort of try and give my own personal perspective on the answer to this question. But I thought I'll start first of all with a simple arithmetic puzzle. All you need to solve this puzzle is some basic arithmetic and some simple logic, so you should be fine with it. It is about these two guys, P and S. Some of you might know the puzzle already. They have this meeting, and they have this information about two numbers, A and B. P knows the product of these two numbers, and S knows the sum of these two numbers. So at their meeting, P announces, I don't know what the values of A and B are. To which S responds, I knew that. I don't know what the values of A and B are either. P thinks about it for a while and says, aha, now I know the values of A and B. To which S responds, in that case, I also know the values of A and B. And my question to you is, what are the values of A and B? Now, what's interesting about this puzzle for our purpose today is actually that this puzzle has almost only ever been solved by writing a computer program to do it. Computer scientists are the people who have gone out and solved this puzzle. And who are these computer scientists? Well, I would say computer science, computing, I'm going to use them as synonyms. It has evolved quite a lot over the years, but there are sort of three fundamental aspects to it that had always been there. At the top there, we've got a sort of scientific element of it, a sort of scientific study of information. To the right-hand side, we've got the technological sort of engineering element of it, you know, the design and creating of machines that automate this transfer of information. And we've got a mathematical element, which I should come back to. I'll just talk a little bit, first of all, about what has happened specifically in England, in the schools in England and Wales, to that subject, computing. It's always been there. It arrived in schools in the 60s, and it's always been there. But it's always been sort of in a little bit corner, in a little corner, usually in the back of the maths classroom. And while it was having its own development as part of the school curriculum, another set of subjects has also developed in the last few years. And for the purposes of today, I'm going to call that commercial studies. It's things like business studies, secretarial studies, accounting, bookkeeping. You know, those are important skills that people need to have. Alan was referring to that a little bit. And so that has been growing as a subject in our schools as well. And then sometime in the 90s, this creature arrived in our school, and this creature had a bit of an identity crisis, because did it belong with the maths and that aspect of the curriculum, or did it belong with these commercial studies? Something else happened in the 90s. The computers became very democratized, and we were faced with a problem, with a real problem, that we had an entire generation of school students to whom we had to give this digital literacy. We had to sort of make them capable of having basic user skills as far as using a computer is concerned. And so I would say that at least in the England and Wales schools, the people on the right, the commercial studies kind of won the argument. The computers were taken away from the geeks and given to the populace. And the subject, which we now know as ICT, basically exploded. And you know, ICT became a compulsory subject in schools and has developed in the way that we know. What is clear now is that things have changed, and that original need for everybody to quickly acquire these skills have gone. And people are beginning to realize, you know, at what cost we made that choice, in that a lot of the stuff at the right-hand side has basically disappeared from schools. All the BBC micros that were sat in the back of maths classrooms went away, and we had this shiny new suites of 30 PCs in the business studies department. And what did we lose about that? One of the things that got lost from the school curriculum was that mathematical element of what computing or computer science is. Now, you're going to recognize what this mathematical element, I think Alan said the word a few times, I would say it's that computational thinking element, which is not necessarily programming. It is much bigger than programming. And you recognize this, and you might call it 4 steps, and it's been referred to in different ways all through today, but it's the opportunity for students to actually develop the skills and the ability to do these things. You've got a problem to solve. It's an approach to solve problems. How do you go about it? Well, first of all, you need to be clear about what the problem is. Create models, use data structures, or it can be done off the computer, but you need to find some kind of abstraction to sort of represent the data in your problem. Then you devise an algorithm for doing that, and this is where it is perhaps different from a lot of the original teaching of programming that took place, and different from a lot of maths as well, and I'll come back to that. You test and refine your solution, and then you apply your solution back. And I don't think it would take much to convince you that actually this is what mathematicians do. This is mathematics. And unfortunately, school mathematics has been mostly sort of taking well-known problems or familiar problems and applying a method that you have been given and that you have learned by rote to those problems, which is not what mathematicians do when they do mathematics. In the same way, this is what computer scientists do when they do mathematics, and programming is just an aspect of that. And people, as computational thinking has started coming back into the speech and into what people talk about when they say, you know, why we need to bring computer science back into schools, and people are realizing what it is that we have lost. Those skills that transcend maths and that transcend computer science. Those are life skills. Those are the things that matter. These are the things that we want our students to sort of acquire. As educators, we want the interaction that we've had with the students to actually result in them acquiring these skills. Whether they do it in maths as part of programming computer science, that's not the point. In a real world, or sorry, in the ideal world, this is what we want the students to gain from education. Unfortunately, that's kind of in the ideal world. In the real world, we're told what we want students to gain from education is qualifications. And so that puts a kind of moral obligation on awarding bodies, on bodies that provide qualifications like OCR, in that we have to find a way to provide qualifications that give educators the opportunities to give students the skills that matter. And it's something that has been quite a driving force in the developments that we've had at OCR. I'll just give you some example, but actually I will use even less of my time, Graham, because Eddie and Tom sort of said a lot of what has been going in OCR, especially with the maths earlier on this morning. We have been bringing computational thinking back into what people recognize as computing and ICT subjects through programming, but through other ways. Actually, quite ironically, what we have done is inside the qualifications that bear the title IT and ICT, and which had no programming in the past, all of those qualifications now have an element of programming. Inside the qualifications that were called computer science, what we have done is actually taken the emphasis away from programming in many places to sort of emphasize more the computational thinking aspect of how you do it. Earlier on this morning, you saw about what we were doing in maths as well, and the work that we have done with MEI. Fortunately, Tom and Eddie are here because I personally know very little about that, having worked on computing most of the time. I mean, some of you who have seen that paper know more about it than I do. But that's the kind of thing that equips students to sort of, when they see the sort of puzzle that I gave you at the start, they can go away and they have been given the skills to kind of find a solution to that. Talking of that puzzle, this is where I say, if you do not want to know the answer, look away now. And it's safe to look again. Thank you.